Hello to everyone. It's my pleasure to be here. Like I mentioned, we had a very warm welcome here in Lviv. It's a fantastic city with great people. We've met very knowledgeable and very skilled people all throughout this week. And so I'm honored to be presenting here tonight. And I hope you're going to enjoy and learn something, get some ideas on the things that we can do with Meteor. And yeah, so let's go into the presentation. The title is Scaling Meteor with Seneca.js. And let's go right into it. Well, my name is Tobias Jaeckel, and I'll tell you a little bit more about myself. I'm a traveler of worlds. I spent about 10 years of my life around the globe outside of my home country. I lived several years in the US. I spent a long time around Asia and of course around Europe. So I have some 10 years of experience in the IT industry. I'm a former executive with Accenture. I started off there in the consulting practice for financial services, moved into outsourcing for technology, and before and after worked in smaller to medium-sized companies and also in a couple of startups. Currently, I'm the co-founder and responsible for technology with GemShelf. Okay, so we have two technologies we're talking about today. And one of them is Meteor and one is Seneca. So let's just get a bit of feel, what is the tools that we're working with. Let's start with Meteor. So what is Meteor? And well, just kidding, because I think you all know it. We're in a Meteor meetup, so you understand what Meteor is all about. But when we go to Seneca, I think it might be a little bit different. So let's have a look at what Seneca is for. So Seneca is a tool set to create microservices with Node. Right? It enables us to stay in the JavaScript world that we're familiar with using Meteor, but it helps us a little bit create solid microservices. It assists you in keeping the code organized, keeping it clean, and make it easy to deploy and maintain the code so that you can rapidly deploy at any time, really. And the great thing is it's also stable. And just recently, well, it's a bit of a luck that they did it this week, but on Monday, they went to version 1.0, right? So it's been a few years in the making. There's a lot of activity right now. There are several committers. And so this is an interesting framework or tool set to look at when you're thinking about microservices to be developed in Node. Okay, let's take a step back and think a little bit or understand a little bit about what are microservices. You're probably familiar with it. It's not like a new concept in general or specifically with Meteor. They've been advertising it that this is a way to scale and make better code. But let's still review it. So what are microservices? They are modular pieces of code, modular services that you can deploy independently, right? And they are small. So each of those services it runs a unique process and it communicates with the outside world through well-defined interfaces, both from data coming in and data going out. So you can regard it kind of as a black box for all the other consumers of these services. And very important, it solves a very specific business case or business goal. So we try to keep things very small, very focused. We don't try to solve everything. So when you compare that to a monolithic architecture where you have a lot of modules and you try to solve many things at once, the microservices have a different approach. So how do we communicate with the outside world? There's various ways to do it. So it depends what you want to achieve. So very often we use a REST API to do this. But it really depends what you want to do. It could be sockets, it can be message queues, whatever is needed in order to achieve your goal. Okay, so we'll take a real life example. We got this great idea for a product, right? And so we start at a clean slate. We want to move and build something great, right? So what do? We build something and we pivot. And we pivot again, and we pivot again. We make changes. We're trying to understand, how can we best reach the market? How can we best serve the customer, right? So we do this and we build something, and what do we get? We achieve our MVP, our minimal viable product. Okay, great. So here we want to build a sandcastle. Yeah, we do have a sandcastle. You know, you can recognize it, and so our product works. You know, first customers are on there, they're happy, and so we can get further information on how they're using our product. So we got a working MVP. That's great, and we've made a lot of you know, fast changes. We altered code because at the beginning we don't know maybe exactly where we want to go or how the market will react to our product, right? So we'll have many changes in a short span of time. So more likely than not, we have some opportunities for refactoring in the code, maybe some better test coverage and things like this. In a nutshell, we probably acquired some level of technical debt. And also we may have relatively high cost of bringing on new people to the team, new developers, new testers, because all our code is likely in one larger application, because it's just easier to handle. Sure, we have a package structure and things like this, but still it's one large set of code. So even if you want to change a small piece, you kind of have to understand more or less everything to make it happen, right? To make those changes. But okay, that's where we are. We're still, you know, happy and confident with the product that we have. Our customers have confirmed they like using it. So we see a great market fit. What's next? Next is we want to conquer the world. We want to build a, you know, a really fancy sandcastle. And what do we need for this? So we have customers and we want a lot more. So we need to build a very scalable, a highly scalable product. And for this we want a distributed architecture. Right? For this we want to separate the code, the concerns, and we want to be able to integrate with a lot of external applications through their APIs in order to better serve our customers. And well, I mentioned technical debt, so we also want to identify a manageable path to get out of our technical debt. That always happens in the beginning when you're in a fast development cycle, right? So let's go and conquer the world, and for this let's look at why do we want to use a microservice architecture? How does it solve, you know, the issues, the challenges that I have just described? So I mentioned this before, but I will repeat it again here. A big advantage is, you know, a service, a small service that can be independently deployed. We can take it out of, let's say, a bigger release cycle for a big product. We can just deploy it whenever, you know, this piece of the code has been updated, changed, and can be pushed into production. They're also easier to understand and modify. And why is that? Because they only cover a small they only solve a small business goal, right? They don't try to solve everything. So given it's a small code, and we would say, you know, develop it in a week or two, that should be kind of the size. If you want to get a feeling for the size of a microservice, that would be it. Yeah, 1 to 2 weeks to develop it or redevelop it. So if something is not so great, you have a fast turnaround to make it better. So it's easy to understand because it's just small, and that also makes it much easier to test. Right? See the service as a kind of a black box for a tester, and you have a well-defined interface going in. You have a well-defined interface of what the client or the consumer of that service can expect to receive. Right? Makes it easy for testing. What happens inside is a different story. Now, since it is a service that works through these interfaces, we can develop it in any language if we wanted to, any technology that is suitable for the task at hand. Of course, we prefer Node, but we could use something else if that was a better solution for us. And now it is easy to scale our application and integrate with other third-party services. Why? Because the scaling can be much more exact, right? If we have a specific function that requires a lot of processing power, requires a lot of memory, then we can simply scale that portion of our overall application. We don't have to scale the whole thing. Right? So we can be much more exact and much more responsive to our needs of having more customers on the system and more demand. Okay, so now we've covered why we want to use a microservice architecture. Why do we want to use Seneca? Right? So Seneca provides us with a tool set, really. We can call it framework, but it's really a tool. It's a tool set. It is stable and actively maintained. It is somewhat opinionated, but it still gives us the flexibility to do things the way we want to do them. Yeah, so it doesn't force a specific way on us. We can adopt it to our needs. So it is a great ecosystem with a lot of plugins that are available from from the Seneca creators themselves, and also from other third-party developers. So we can use these plugins and we don't need to reinvent the wheel, right? That's always good. We don't have to write everything from scratch. But also we can write our own plugins, of course, whether they're public or private. And so if we need additional functionality that is specific to our application, then we have this clean way of extending the Seneca tools to suit our needs. Yeah. And what's also nice is it already provides us with a data access abstraction layer. So that means we might interact with a database, let's say Mongo, or we might interact with flat files, or it could be Redis or whatever it is. We have the same way of accessing this data. So if you want to switch later on, we only need to change that plugin and how to access the data, and we don't need to change our code. So you can already start working. You don't need to worry about database setup or such. Just store it in JSON, for example, and later when you're ready to go to bigger solution, use Mongo or Redis or whichever you prefer, right? Whatever is suitable also for that task, of course. And it's also great we can continue using Node, so we don't need to go to a different language. Okay, so we'll look at a Barebone Seneca service, and I hope you can read it back there. So this is so what we do is we get the Seneca library, right? And now we add actions. We define actions, right? And so here we have two parts of that action. At first, we create a namespace. In this case, it's the namespace to-dos. Yeah, and then we have various actions or commands on it. In this example, it's create. And now inside, so this is not a complete example, eventually we have a callback, but before that we will create some data that we will send back to the client, right? So this is a very simple example of the server for Seneca. And now if we go to the client side, so the client side triggers the action. So here again, you see the namespace to-dos, and you have the action create, right? And then here you obtain your callback, and in this case, okay, we'll just stream it out to the console, and you see we have an object with a structure. In this case, we created a to-do, and here's what we get inside of the result object. We have our to-do object. How exactly we want to structure it, that's up to us. Yeah, but here we have a very nice let's say abstraction of our different namespaces of our actions, both on the client and the server, and then we can see easily how these work together. Okay, this is just a barebone example, and of course we want to do more. And as you can guess, I think we will do a to-dos app, right? You know this from the Meteor example or the initial tutorial. So we'll do something similar. And what are the goals? We want to do all the, let's say, the heavy lifting, the business logic, the data access. We want to push this away from Meteor onto Seneca, and to make it a little bit more interesting, we want to retain reactivity, because that one is a little bit tricky, right? Okay, so how can we do this? So on the left side we have Meteor, right? On the top you have the client, on the bottom you have the server, okay? Top right you have our Seneca microservice, and then we have the Mongo database in this example. Okay, let's start with the client. So the user triggers certain action on the user interface, just like normal. We trigger a method call to the server. We prefer this because we have a little bit more control. Okay, and then what happens is the server later acts on this action. But also we subscribe to the publication of Meteor, just like we would do normally. So nothing really special here on the client. Yeah. Okay. So what does the server do with the method calls, right? it doesn't do anything really. It just proxies those calls onto our Seneca towards our Seneca microservice, right? So this is a little bit different. What you see here is the logic that we normally would have inside the server to act on our requests. We move it away. Okay, so as we start, we trigger that initial. We need our initial data set, right? Because here we need to send the publication data back to the client. Yeah. So we subscribe to the publication again, same as normal, and now we need to push the data. So what happens is our initial Seneca action to list the existing data goes to our microservice, and it returns already our list. We now manually update the publication, and then we trigger the event. And so on the client side, there's no difference. There's no difference, right? We have a little bit extra work here on the publication for the server. We'll see that later when we look into the code. Now, what happens on the microservice is that we have read-write access to Mongo. So what you'll see is the Meteor application doesn't even know about the data source, doesn't know if it's a Mongo database, is it a text file, and it doesn't care, right? Because our microservice takes care of it. Seneca takes care of it for us. Okay, so we have the read-write access here. And now here we have an optional a part here. We want to show you reactivity, so we decided, okay, let's do this then via WebSocket. So at live, at runtime, we can push the changes straight to the server, right? So we register, we listen here to the socket, and then we just provide the messages as we read from the database. That still doesn't give us reactivity, because how do we know that there's updates? And so here, let's say, to keep our lives a little bit simpler, we just tail the oplog in a similar way that Meteor does, right? So any changes, any events that the oplog provides us is received by Seneca, right? And then it triggers the changes back to the Meteor server, which then updates the publication and sends everything to the client again. Just, business as usual. It's just done in the same way. But that's optional, right? You don't need to establish that socket, because not in all instances do we really need to have that reactivity or the live data. Maybe it's enough to poll every once in a while, right? Because a text file will not give us a true real time. It may not be needed. So it depends kind of on your use case, what you want to do. Yeah. But we can achieve it, right? That's the point. We can achieve it. Now let's look at the code, right? It gets interesting now. On the Meteor client, basically everything is normal. So that's the whole point. There's nothing else, nothing special here. So we just, like I mentioned earlier, we choose to define events and helpers to interact with our Meteor server, because it gives us more control. So the point here is you see nothing special. Okay, it's just normal. Okay, let's look at the Meteor server. And so here it's a little bit different, but very simple. We just stripped out the logic from the server, and what we do is we proxy the requests here. So we have, we want to create a to-do, and what do? We trigger the Seneca action in the namespace to-do with the action create. Yeah, and what do we do on top? We just initiate a Seneca and wrap it so it's fit for use within Meteor. And so here are the three actions that we have. We have create, we have remove, and we have update. In our case, the to-dos just has one update. We can mark it as complete or incomplete. Yeah. Okay. And remember, the initial list comes to the method that we sent in the beginning. So now we only have updates for the subscription. Okay, now how does the publication look? And here's a little bit, a few extra things. So when we subscribe to the publication initially, we reach out to the microservice to receive our initial data set. And then once we got it on our Meteor server, we push it to the client. And then if we want to maintain the reactivity, like I mentioned earlier, we establish a socket connection to receive updates real time, and then again we push them to the client. And when the client disconnects, so user navigates to different site, okay, we disconnect, and here socket stops. So a little bit of extra work here, but not overly complicated. And again, we moved away most of the logic here. Right? Now let's look on the Seneca side, on the server. So what we do here is we listen to the requests and perform a particular action. So I'll highlight this again. This should look familiar already. So here we have, again, namespace to do with the command create. We have the update, or in this case, check. We have our remove, and we have our list action. And so what Seneca gives us here is it provides the Seneca entity API, and so it abstracts away from us how do we access the database or how do we access the data source per se, because it doesn't need to be a database anymore. So the last building block that we have is we need to establish the oblog tailing. Right? So we listen to the events and then we push them back to the Meteor server through the socket, in this case that we established. This is an example here, right? We don't need to use oblog. We just chose it here because it helps us to keep things a little bit simpler and to really achieve the reactivity. But there's other ways that you can do. For example, I mentioned polling earlier. So let's say you want to integrate Elasticsearch, yeah, and you have a search result from that. Elasticsearch doesn't have oblog. So how do we get the data? So now it's up to us to determine what do we need. Yeah? Do we need near real time? Then maybe we will establish a polling relatively frequently, or maybe we don't need this. Yeah? There's also other ways. Let's say now we deal with maybe one microservice. What if we have multiple instances? So now they need to communicate possibly with each other. So we could establish sockets between the microservices. They perform particular actions. We put things in maybe in a queue, and they can among each other understand what kind of updates has happened on the data, and so keep our Meteor instance up to date that way without directly tailing the database. Okay, so let's look at the demo and see that it actually works. Right? Okay, so here we have the microservice. So I'm going to start this up. Okay, and then we have our Meteor application that I'm going to start now as well. Okay. All right, so I'm just going to reload this now. Okay, and what you see is, well, we have an application running and it's an empty to-do list. So what do I need to do? I need to see if this really works. Okay, it created a record. Let's see, what else do we need? We need to hire a front-end developer. Okay. So, well, is it reactive? Let me see, do I have another window? I have. Okay, I'm gonna start this here too. Okay, I got the data here, and let's try to hire a backend developer. And so you see that the reactivity is still there. Right? We can perform some other actions. We can say we mark a task as complete, and we can also delete a task, and so we maintained reactivity even though all data access, all the actions didn't happen in Meteor, but they were performed on a microservice Seneca. But why would I want to bother, right? There's this could be, something to think about. So this is not one size fits all, right? So it depends really on your use case. Why? So you could, if you're really only in the Meteor environment and you want to use DDP and that's all you're going to need, maybe you're better off building microservice directly with the Meteor framework as well. In our case, we have a need to interact with a lot of external systems. And so our microservices are not only consumed by Meteor, but they're consumed by other applications as well. So this could create a need to go outside of the Meteor ecosystem and let's say get some, maybe additional flexibility or some further tools that we can use to make the overall experience for the users better. So what I've shown you here is today is that you can use microservices in a distributed environment to scale Meteor and keep the reactivity. And when we go back to the presentation, here's a couple of resources that you could look at. So the Seneca website has a number of interesting tutorials, videos and explanations. Like a main maintainer of the Happy framework explains how you can integrate Happy with Seneca, for example. And there's a lot of interesting information that you could look at and a pretty good documentation as well. I think some explanation about microservices, and if you're interested about the oplog, you can check it out as well. Of course, there's many other resources that you might want to look at. Okay, so if you have any questions, please come forward. I'm going to answer the first one directly. Yes, of course, we're hiring, and you can send me an email at this address. And now please go ahead and shoot some questions.
What was the greatest challenge you faced when you decided to move to microservices?
Okay, so that's a great question, right? So when we worked on the Meteor application, we made sure that we follow a relatively strict structure of packages and keep the code already self-contained. The challenge is to identify, which pieces we can easily move out or which we need to move out, and then how will they tie back into the application. So what could happen is you have certain dependencies that you need to cut and make the code really clean to move it out. I think this would be probably the biggest challenge. Yeah.
Is it like a piece of logic? How do you choose this piece you want to switch out?
Yes, it's a piece of logic. So we also have chained microservices, right? So we have a microservice then that in itself cascades certain demands towards other microservices. So let's take an example. In GemShelf, we call our content gem, right? Everything is a gem, a precious piece of information, right? So this is the central piece of knowledge, but it will not take care of everything. It has, for example, it needs a preview image. Okay, so how do we generate a preview image? That's not part of that microservice, but the GEMS microservice that takes care of creating and updating, that piece of content itself will then delegate the creation of thumbnails to an image microservice, right? And also we use, I mentioned before, Elasticsearch. Not only do we need to send the data into Mongo, but we also index it to make it findable, to make it searchable, right? So then again, we cascade into a microservice that wraps around certain functionality of Elasticsearch, okay? And then we have we have attachments. So now that gem microservice receives an attachment, but it will not take care of it itself. But again, it goes to another microservice that deals with handling documents, extracts the content, and then sends it into Elasticsearch for indexing, or create a PDF preview for it, right? So it's kind of, you need to think of what's the flow and how to keep things clean. Yeah, so you don't create a god microservice that needs to know everything, right? This can happen, so you need to be careful to not do that.
I had a question about transporting data from. I had see your examples on your official site, and I had not see any way of transportation. You had to talk about sockets, but there like could be a function which had 1+1, and there in which way I can add transporting in your Seneca.js.
So when you trigger the action from the Meteor server, right? That's when you call Seneca act with this role and this command, right? So you send a data object, right? And so you provide data, and then on the Seneca side, the microservice receives this data on this particular action, and you will write any code you want, and again you return a data object. So inside the on the microservice, the service side, you perform this, and the client then receives the result. Was that your question?
Yeah, maybe yes.
Yeah. Okay. It's a normal method, right? So you can do whatever you need to do there, right? And then you just return to the callback. Mm-hmm.
So the main question is, why are you using Meteor? What is the benefits of using Meteor?
What's the benefit of using Meteor?
You have a complicated structure. You said that you have different resources, MongoDB, Elasticsearch, maybe different even third-party data sources. And I'm going maybe to use Cordova functionality of built-in, so also build mobile applications.
Mm-hmm.
Or you just only use a web part of Meteor?
So currently we use the web part of Meteor. I mean, the main selling point of Meteor is the reactivity, right? You don't need to worry about it, it's just given to you, right? So that was a big selling point for us. It's an up-and-coming framework. There's a lot of exciting things around it. But of course, you can achieve similar things with other frameworks. So why would you use Meteor? That's maybe too broad a question. For this forum, we can discuss maybe later.
If you look at other framework, for example, Angular, it also has data binding way. So it seems if you just need to automatically refresh the content in way if something changes in data source.
Of course, there's many tools to achieve that. So it's not that Meteor is the only framework that can give you this functionality. You can build it with other tools. What's interesting though is you can, I don't know how far it is, but I think that you can already use relatively easily Angular together with Meteor. So it's not like one or the other. So Meteor becomes a little bit more open to other components. In the beginning we just had Blaze, now it moves to React, but Angular is possible as well, right? So regard it as a framework, as a set of tools, and for whatever you use, whatever you want to achieve, you pick what's best suited for the job, or maybe also what's your taste, right? What do you like better? So Angular is also fantastic, but Angular in itself is not what Meteor gives you. Meteor gives you basically end-to-end. It covers everything. What we now talked about microservices is, it's an architecture, it's a pattern that you can use with any framework, because now we want to scale the backend, right? And want to make sure it's distributed, and we can target the pieces of our application that we need to scale.
Thank you.
What kind of interfaces do you set up between your REST, not REST, but your microservices and Meteor server? Is it REST API or WebSockets, or does it differ for different?
It depends. So in this example, it's a WebSocket, so that we can achieve reactivity, but it may not be needed, because it's a resource intensive to some degree. So if you only need periodic updates, then a REST API is just fine. So an example would be, I have search results, and I don't want them to constantly change, right? I filtered, and I want to see my results and choose where to navigate next. And just because someone does a bulk upload, I still want to see what I searched and not have some kind of, disco effect on my screen, right? So in that case, reactivity is actually, harming the user experience. On other parts, it's exactly what I want. If it's more of a like a communication, or where I need real-time interfaces. So, it depends. It depends what you want to achieve. The point is you can choose different means. You're not bound to using just one.
And how difficult is it to run locally on the whole setup? Because you probably have not one microservice, right? So you have to run the whole sequence of those services.
You mean in local development, yeah? The good thing is you don't always need all microservices for whatever you code. So one big advantage is that, let's say you need additional functionality in the service in that particular piece of code, you don't need to run anything else really, to simplify it. Yeah, you develop that particular service, you can easily test it by, data in, data out, right? If you need to more integration, of course, or you're more connected, then you need to spin up the microservices maybe that you need. But if I'm not concerned in how data gets indexed, I don't need to run it. Or if I'm not concerned if my preview images get generated, I don't even need to run that service. Okay, so let's say it fails, but I'm not concerned about it. So sure, if you have 100 services, it gets a little bit more complicated. So we move complexity somewhere else. So it's a trade-off, right? Whatever you do is you will not have only advantages. You will always have, a pro and a con. So you need to weigh where it makes sense. So it probably doesn't make the sense to create 1,000 microservices when you can do with 20. So it's a decision you have to take.
So, for example, if you have 20 microservices and you have quite a big team, and need to work separately, different team maybe in different countries, for example, with different time shifting and so on. And for example, you have cases when two teams need to modify one microservice. Could you please describe us how did you make this working from perspective from different version control and CI? Do you create like something like git slave and creating separate branch for each feature, or you just have maybe a config file where you have like an URLs or something else for different microservices, and in case if you use modify only two of them, you can override this config file and use only these two microservices locally. Because it's a very interesting question. For example, in my current project, we have like the similar problem, and we're trying to resolve it.
Right. I think the question is not necessarily microservice specific, but it's general development. So this is not a special piece of software. It's a code, right? If you work in a team, with distributed teams, it's the same process. We had the advantage that we didn't have multiple people in multiple time zones working on the same microservice, so we didn't encounter this. But in general, best practices in software development, versioning control apply. So you build your own branches, you merge. What's important with the microservices is that as you change them, you keep the interfaces. These are well-defined interfaces, right? They don't change so much to the outside world. So even if you change something inside your service, it normally should not affect the outside, right? You change something, you fix something inside the service, but the consumers, they don't really care about it because the interface has remained the same. They're not affected, right? That's an advantage here. So actually the problem you described is much bigger when you have a more monolithic setup because you're all working in the same application. Now you have more separation, so it's easier to manage. But you go through the regular versioning control, the branching and such. So I think there's no big difference here.
By the way, are you using plain JavaScript or like CoffeeScript or some?
Plain JavaScript.
With ECMAScript 2015 or?
Not everywhere, but some. So the newer pieces, yeah.